Now come to the second point, which is effective frontal area. Effective effective frontal area. Effective frontal area means, suppose there is a structure. There is a structure. Suppose there is a structure, and wind direction is this. Direction is this direction, and the face perpendicular to the wind direction is called face perpendicular to the wind direction. Suppose we take a plan view of this. Then we can say this is perpendicular to the wind direction. So this is called the effective frontal area. Effective frontal area. Now come to the other point. Effective surface area, the area of the surface over which the pressure coefficient is to be taken constant. Force coefficient, the non-dimensional coefficient such that total wind body is the product of the force coefficient, the dynamic pressure incident on the design wind speed, and the reference area over which the force is required. We come to these parts in later chapter, and this also we come to the gust, this also. Now come to this point, the phase length. This is the distance measured along the wind at which the change in the type of the terrain occurs. It is the distance measured along the wind from a boundary at which a change in the type of terrain occurs. When change in the type of terrain encountered, such as boundary of a town or a city, the wind property changes, but such changes are gradual and start at the ground level and penetrating upward by the increasing phase length. Now come to the point. This is called phase length. Depends the distance wind travels over a uniform surface without significant obstruction. When a change in the terrain type occurs at the boundary between the open country and a town, or between the land and water, the phase length is measured from the point at which wind first encountered the consistent terrain to the boundary where it changes again. That means, suppose these are the buildings and these are the buildings. So wind first flows from this way and this way, and the length, and this way and the length this way. This part is unobstructed. So this length is called fetch length. This length is called the fetch length. Now come to the point, the high-rise building and the low-rise building. If the line a height of the building above 50 meter, if the height of the building above 50 meter, then it is called high rise building and low rise building. If height less than 20 meter, then it is called low rise building. Mean ground level, the ground level in the at in at average horizontal plane pressure coefficient. We come to this point. We come to this point in later stages. Now come to the main chapters. How the wind speed are calculated. In general, the wind speed is the atmospheric boundary layer increases from. In general, wind speed in the high atmospheric height layers increases with height from zero to ground level to the maximum ground level at a height called gradient height. The wind speed in the atmospheric boundary layer increases with the height from zero at the ground level to the maximum at the height is called gradient height. It is usually a slight change in the direction, but this is ignored in the standard. The variation with the height depends primarily on the terrain condition. However, the wind effect at height never remain constant. It has been found that convenient to resolve its instantaneous magnitude into average mean value of the fluctuating component around this average value. The average value depends upon the time employed in analyzing the meteorological data, and this averaging time varies from few seconds to few minutes. The magnitude of the fluctuation component of the wind speed, which is called gust, and depends upon the averaging time in general. Smaller the averaging interval, more is the magnitude of the gust speed. Now let's describe, or let explain what is the meaning of this paragraph.